site is quite likely to restore all the service. Then if we have some mechanical cutting of the fiber, it's just necessary to put some splice or some way to reconnect the fiber. And we don't need to worry in case of low tension of other affected portions of the fiber. What's completely different in the case of high tension mechanism. An example is a backhoe dig up or a fallen utility pole. In this case, not only the specific point when the fiber was broken suffered some damage, but also some other region nearby. Then the choice of restoration method must consider more than the visually obvious aspect. Cables damaged in high tension, the gap should be replaced with a spare cable joint to joint as the preferable emergency restoration method. It means that sometimes in this high tension event, other portions of the cable could be affected, and the mechanical resistance of this portion are not the same as we need to have the system working. And if the people just put a splice, some days or months later, we could have another break of the fiber in the nearby region. Then the idea is to repair a permanent, considering a longer extension of the cable. Okay, there's a way of, yes, it's some kind of repair like this. If we have a dig up here, it's better to find some higher extension of the cable and put a new emergency cable, and after that repair cutting long sections of the cable in case of high tension failure mechanism. Of failure, the idea of permanent repair has priority, but is necessary to plan well to avoid duplication of work or service interruption in the permanent repair after the emergency restoration. The recommendation is that the emergency restoration required in such case when the same way when conducts are broken in a backhoe. The procedure to be used, one of the recommendations is that the restoration procedure should are based on a premise that optical fiber cable system carry large traffic cross-section and warrant a substantial investment of manpower and other resources to assure that service interruption are minimal. Then if we are in that case, that we have large traffic and it's necessary to put the cable again in operation as soon as possible, the first procedure to establish is planning and readiness to do the critical activities is very important. Initially, the system must be efficient. That system we shown before, the relation that the company established between information related to the network and defaults, it should be based on to be ready to act as soon as alarm or voice communication are activated related to that fault. And this alarm and voice communication system must be efficient and well maintained. It's necessary also to have emergency materials and equipment in a centrally located location, and systematically inventories and maintain procedures are necessary. The documentation on circuit assignment and their relative priority must be up to date and readily available. And it's necessary to have a plan to rearrange this circuit. And it's important also to have designed some responsibility. Then the coordinators of this restoration and the teams should be well trained and available 24 hours a day. That is important to have a plan of how to act in this occasion and to have the mechanism, the instrument, information, and the people ready to do the activities. Having all of this in mind, when damage of optical fiber has been reported, located, and evaluated, then we know that happened, we know that where it's their position, and we know it's a case related to the optical fiber. The method to be chosen for provisional repair depends on the identification of that two situation, the low tension case or high tension case. Is more useful to have a method for do a provisional repair in almost most of situation because it's fast and reliable. Then the faster one and reliable one is the joint-to-joint cable replacement. With this method, the teams in field disconnected the joint of each of the damaged cable and provide in its place, either in a spare duct or above ground, an emergency cable. Then to use this, it's necessary to have all these emergency cable ready for use. And this is very useful to have in a centralized position and ready for put in case of necessity. For most protected roads, it's sufficient to stock one long and one short cable and approximate maximum fiber counts and fiber grade. And the idea is to have at least two sets, one used in long and other used short cable, and all of this with the maximum fiber count used in the network. And this long and short must be defined in function of each optical network. This method avoids excavation and allow the restoration without precise fault location. And works also in case of distributed fiber breakage and permits a substantial advanced planning to eliminate roadblocks. Then the idea is to have this emergency kit cables to repair and go faster to the location and put this new one using a situation similar like that. Sometimes people keep all this splicing connected to the emergency kit, and in field they just connect the other side to this one. If there is a list of more critical fibers, as I've mentioned before, this fiber is put in service as faster as possible, and the other fibers used for emergency or not using this cable could be spliced later. After this provisional service is provisionally restored, there is a number of important decisions related to the repair more permanent to this damaged section. First is necessary to assure them that the fiber damage was where it was happened in the original cable, and trying to provide some tests and permanent repair of the cable. Most of the time it's necessary to pull another cable in the same duct, spend some time to reconnecting these fibers, then remove this set, and this emergency kit is ready for another use when necessary. Another important thing is that as we implement the permanent repair, it's necessary appropriate service rearrangement to correct any temporary circuit assignment and end-to-end conformance test performed to ensure that the system standards are met. Generally, when we have this kind of situation, other actions occur with other parts of the company. Then it's important after the correction that this new part of the network is tested and all the information are reported in a way to that the database and the people involved have the real idea of the new situation after the restoration. It's very important to do this because sometimes we take more attention to the activities related to the reestablished service, and if not done the exact actions to inform it, to actualize the database, in the future it could cause problems. Some question about this recommendation? Yes, sir.
Thank you. When you have a cut or when you have a fault between two manholes, and when the two manholes are there is a big distance between the two manholes, what is the suitable distance you can leave in the when you splice the place where the fiber was damaged? What is the distance you can leave instead of building if you build a new manhole there where the fault was occurred, and what is the loop, the distance you can leave in that manhole?
Thank you. It's important to know what kind of access we have in this cable. Imagine you have just, if you have access in this region, you can use as a reference. If not, there's no way. You need to go through all the distance between one another. Okay, yeah. Because the main point is that here we have a bird or we have a cable in duct. If we have some possibility of faster access the cable, we can consider is that as part of the repairment activity. If not, imagine we are going from Kigali to here, and you have just access in certain point. What people use to do sometimes is to look if there is some aerial network and to put a long extend cable using aerial just before to have the opportunity to put another cable on the duct. And the worst case, if you have a buried cable, to reestablish the initial condition, you need to bury another cable. It will takes a long time. And I mentioned during the presentation of aerial installation, cable in aerial installation, that the cable designed for burying or ducts, they are more stronger than the cable used in aerial installation. One thing sometimes could be done, imagine you have some distance here, such as 2 kilometers or something like that. And if there is some aerial network here, it could be used for establish, even though the permanent cable. I saw this sometimes. Imagine you have a buried cable, you have a good, there's a bad disaster and affects a lot of high-level breakage of the fiber. It was just some dig here, and sometimes it's difficult to put the buried cable faster, and some people use also for the temporary as for the permanent use aerial in this case. Then going to the best situation to the bad situation. The better situation could be have access in some intermediate point. Then you could put a splice box there and 2 points. Imagine you have an access in intermediate. Imagine it's 2,000 meters, but each 500 you have some kind of access to the ducts. You can choose 2 and put the cable, or you can choose just 1 and put a long extension of cable. If it was a low tension fiber, you can put all in some position and splice the fiber. It's a high level tension. It's necessary to change a large amount, typically around 25 meters of each side of the cable. The numbers I have in mind when you have a D of the cable is to cut around 50 meters of the cable in each side of the damaged cable. Then, in the worst case, is to change, in this case, all the extension. If it's in duct, you can use an aerial just or some. I saw a lot of different things. Sometimes the people has a wood aside the road, and they just put the cable in floor, going a little far from the road, and just take care of the cable for some period, the temporary. And after that, if it's a duct, provide the pulling of another cable in the duct and remove the temporary and put the new one. But if it's buried cable, sometimes it's necessary to burn another cable, or another choice is to use the cable, use it in buried application to have some aerial portion of the nectar. Depends on the time, depends on the materials people have nearby, and depends on the investment the company wants to put in there. The first important point is to have in mind the real situation. Imagine you have 15 sections of 2 kilometers of cable. You need to have a wheel with 2 kilometers of cable. If this cable is critical, you need to have a reel with 2 kilometers of cable with splice box in both, easy to put in field. Or you can do another way. If it's more expensive to have more than one cable, more than one route. It's more critical when you have just one cable. Imagine that figure the minister showed on Monday. You have a lot of expectation related to the optical fiber cable. And if you have just one cable in a lot of direction and lots of 2 kilometers segment, it's not difficult to have one kit ready for use using a 2 kilometers reel and fasten, put this in a temporary way aside the road and to have the system working again. It's easier to have this long length of cable and then to bury or to do another things. Yes, sir.
Thank you. Then when we have a buried cable, what is the recommended distance between two splicing points? What is the recommended? What is the best one for a fiber which is going to very long distance?
Most of the time, people want to minimize the splicing box, minimize the access, and use the extension as long as it's possible. Then it's usually to find extension that is related to the length of cable you have in the reel. If you buy 2 kilometers or 2 kilometers and a half, for the system there is no problem, because in case of buried cable, you don't need to have strong worry about the pulling tension. If you have a cable installed in ducts, that first consideration related to pulling force, that will determine what the distance. Depends of the case of the duct and so. If you have good ducts, it could launch far distance. You can use as far as possible. In this case, there are some compromise. The more longer is the cable installed, the less splicing box it's necessary, and the less access boxes are necessary. But in this case, the longer will be the cable we need to repair temporarily.
Let me just give you a real example. Suppose that you have between two manholes, you have like 2 kilometers. Then at the middle, you have a cut. Then when you want to repair, what should be the best solution is to build a manhole at that point and leave some coil inside, or is to replace all the 2 kilometers fiber. And what are the consequences of having two joint box in the same manhole and leaving so?
No problem. If you need to have more than one splicing box in the same manhole, no problem, considering the other situation. If you need to have this, imagine you don't have. Well, let's think in two situations. The first one is that this is a low tension fault, just in the middle of this 2 kilometer length. Then you have the temporary kit to put here, solve the problem at the first moment. And after that, you apply the OTDR, you know exactly where the damage was done. And imagine this damage was because of some cutting action. The people someone was trying to dig a hole and cross the cable. Then the cable just receives some mechanical action. It is characterized as low tension damage because it just was cut. Then you can build a new facility, new manhole here, and just put some extra length. Most of the time it's necessary to put 2 splice box, because you put one and other in, put an extra length in between both, and 5 or 10 meters. It's the same situation. You need to consider if you are installing, imagine if you are installing a cable, if for any reason you need to put 2 splice box in that manhole. Then recommendation is to leave 5 or depend the case, 10 meters in each side of the cable. Okay? If you are installing since the beginning 2 splice box. But in this case you described, you are just installing 2 splice box here just to reestablish this cable. Then you will have some few amount of cable in each side. Sometimes it's hard to get the right. One thing that could happen is that if you have 5 or 10 meters, imagine the good situation. You have a splice box in this manhole with 10 meters for both sides. Then you could pull 5 meters to here and have an extra 5 meters here, and do the same in the other side and put 2 splicing box, or depend this, if you have 5 and 5 meters, you can put just one. Then in this case, if we were conservative and let 10 meters of cable here and 10 meters of cable in the other manhole, we can use 5 meters to stay in each new end of the cable. If we have 10 meters here, 10 meters here, we can go to the good situation and keep 5 meters here, 5 meters here, and put part of this cable and have 5 meters here, and put part of this cable and have 5 meters here. And you use just one splice box. Yeah, you can. Oh, sorry. You can build a new manhole here and put this new situation in 2 or 1. If you have just a few amount of cable, just enough to do the splice in a splice box, is recommendable to put 2 splice box and leave some extra cable between both. But by the other hand, if you have the opportunity to use part of this extra length cable to pull to here, okay, you can, in this second scenario, someone will have in the new manhole 5 meters of extra length for one side and 5 meters extra length for other side. Then this can use just one splice box. Okay, it's a good situation. The one that arrives after will find what? We'll find a manhole with a splice box with 2 extra length of 5 meters each side of the cable. And it's a good and a recommended situation. Then the idea is to apply this basic recommendation in the way to have a correct adjust. In case we are always thinking about low tension failure. If there is not a man just cutting the cable with his hand instrument, if it's a big dig made by a machine and the cable was suspended, sometimes they pick up the cable and suspend meters above the ground before broke the cable. And I saw sometimes also that the cable, the fibers, at the first moment, they were not broken. It was some increase of attenuation because of the strain of the fiber inside the cable. And it was a high value of attenuation that when the table was relieved, the attenuation returned to the normal level. And the people involved with this accident need to decide what to do. Because if they consider the mechanical properties of the fiber were not enough to withstand a lot of years, they can change at least 25 meters of each instantia. In this case, it means to build 2 manholes, if it's a bird cable, 2 manholes at least with distance of 50 meters of distance, around 50 meters, or decide just to lay down the cable and look carefully to that cable, because it's not for sure the fiber will break in this second case. The fiber could break and could take days, months, or years to break. Some decisions sometimes are done in this way. Okay, I know the cable was mechanically affected. I know the fiber didn't break. I know that attenuation goes to the normal level. Then I will let the cable this way. If some fiber break, I, in the future, do some action to correct this. I try to cover all the situation. And of course, the reality is more richer than our mind, né? And the world always puts some different things near us. But the main point I would like to address in this is that, first, the kit for emergency needs to be, most of the time, at least one for the longest and worst situation, and another for short and more common situation that we can find in the network. Second point, it's necessary to see carefully in this long distance what are the importance of the service are passing in that cable, and if we have redundancy. One way to solve most of this problem is to have as possible to have some redundancy, and most of the time ring configuration. And if this cable is in a ring configuration, we just route the service to the other cable and reach the same position, and have more time to reestablish this fiber. If there is not the case, if this case special cable is in a critical route and we don't have other way to reach that location, it's good to have some emergency kit that allow to reestablish the cable, even though putting this cable in a very temporary situation, like just lay down in wood near the road, or put in a temporary aerial installation, and after that act the way it's necessary to reestablish the cable. It's why this strategy is so important. We just need to follow this always, to reroute the traffic, to locate the damage, temporarily reconnect the damaged cable if it's necessary, and then restore the service in the way we choose to plan at the beginning. That's it. It's always, you need to always to have in mind this. Another question about this? It's funny because in Brazil we have some roads that one important one, it's between São Paulo and Rio de Janeiro, and the first optical cable that was installed there, it was cut a lot of times because of unexpected reason. Once the guy was digging up a big hole to put a dead horse inside the hole. The guy decided to move his fence and put the new fence just in the same position the cable. Then the people that are involved with the telecom company is starting doing a lot of information, because there are a road with 400 kilometers, and they start doing a lot of interaction with the people, trying to give information how important was the service they are receiving, and what was the connection between that service and that cable installer aside the road. And some years later, this road was privatized. Then we paid to use this road to a company, and this company did the opposite. Uh, Besides take care of the road and also take care of the cable, this company that run the street, the road, decided also put his own cables to sell the, the best way and sell infrastructure to other companies. Then at the beginning was in a worse way because every cut of this fiber, it was necessary to act and act again. And after some time, all this kind of procedure became the work more easier. And another city is connected to São Paulo is Belo Horizonte. And the main problem was the company installed the cable just aside the highway, and the people decide to duplicate the highway. The number of fiber breaks, it's around the same distance, around 400 kilometers. The last time I saw the number of fiber breaks of that cable was around 108 fiber breaks. Then they start with a buried cable, and they finished. They wait the company finish duplicate the highway just to put the new cable. In between the two moments, we couldn't find more aerial cable temporarily installed than extension in the cable buried. It was in sometimes people ask they used to put armed guards near the position the people were working with machines, because this big number, of course, it was of irresponsibility of the people who were doing the digs in the way, and they knew the telecom company, the number, they knew sometimes once at least they dig up the cable and call and says, we find a cable. And the guy of the company says, oh, but we are not seeing any breakers here. And he said, no, but we will move the machine now. And just broke the cable, and the guy on the other side of the telephone just noticed the fiber was breaking because the system shut down. And after that, they decided to put, the telecom company decided to put armed guard near the cable, and just to help the guys with the backhoe to remind that it's important not to break the cable. It was the worst situation I ever saw in my life. And they just waited they start doing some kind of this. One of the measure they decide to do is that what will be the next extension of the highway the company will work. Then they just put another temporary before breaking the other one. And then they are turning the buried to a aerial in the same way the company was building the highway. Then it's the worst I've saw on this, but now it's okay. Another important point of maintenance that is in the handbook is the maintenance of underground plastic ducts. The one important point to have in mind is that placing cables in conduits, it's a good choice because it has an advantage that the cable placement operation is separating time from the actual conduit construction phase. Also, the protection that the cable will have in this conduit and the possibility of repeated access, cable removal, or installation of cable in a future moment make this method of placing cable in ducts very attractive. Uh, the disadvantage is that the costs of the conduit construction that it's quite expensive. Um, Another important thing to have in mind is that the underground ducts are prone to being deformed by burden of earth pressure, which make it necessary to check if the duct it's okay before the cable installation. And if find some abnormality, the idea is to repair the defective duct before placing cable into this conduit. Um, as the conduit is installed, a trench has been backfilled before any some surface construction begin. It is a common practice to check the quality of the duct because certain plastic duct can become oval shape or can be pierced or can be broke. Then it's a way to see what's the quality of the new built conduit. There is a lot of defect that can be found in this case, in this kind of infrastructure. One is crack or fracture, and the main cause are excessive pressure on conduit or insufficient duct strength. Another possible defect is duct failure, and most of the time is caused by ground settlement or excessive loads. Another possible defect is pointed deformation, most of the time due to sharp-shaped crushed stone. It's usual also to have an oval-shaped deformation that can be caused for a lot of reasons, including excessive pressure, insufficient duct strength, and dynamic compacting load during construction. Another defect that can be found in this installation is soil intrusion, generally caused by disconnection of duct and also offset of duct, mainly because of faulty construction or ground settlement. In case of any of these defects, we need to pay attention to duct repair methods. And sometimes most of the situation could be happen now here near here in your companies, or other is not so used to happen. The conventional method to repair are open, cut, and dig and replace. Of course, this method involves the direct replacement of the defective section and put a new duct in this open cut trench. It's simple and reliable, but it involves aspects related to the social, related to the occupation, again, of the street to do this, and also costs. When these costs are negligible, it's recommended to use, are not negligible, when we have some expensive work associated to this repairment, one possibility is to use the trenchless technique. And there is a lot of trenchless technique we discussed before. Any one of those, another one using more for repair than installation could be used, such as high pressure water jetting, insertion of a suspension device, or more sophisticated remote control device, a robot with CCTV monitoring. This table shows a lot of possibility of use for test, for inspection, and for repair methods. Then let's take an example. When you use a duct rod, that's a tool that's used to pull through the duct rod, and if we can pass the whole length without any difficulty, it shows that the duct is okay. There's another way to test this is using a mandrel. Can pass the whole length without any difficulty, or you can have some difficulties. Depends on the case. We intend that it's no need for repair, or the use of high pressure water jacking is the best way to deal with the situation. If the defective are more related to debris or sludge, or it's easy to clean. If the defect is more related to ductile failure or cracks or deformation, there is some options. One is the dig and replace. Another is the use of instruments to just repair the damaged section. And the inspection with camera most of the time allow to have more detail and help a lot to choose what could be the alternative to be used. As we are more in a non-urban area, sometimes it's easy to replace. And if we are in an urban area, sometimes it's easier to have, it's better to have the use of some method just to remove the irregularities and not to do all the trenching again. Any question about this or any comments? Yes, sir.
Suppose that you've already put the duct inside for a long time, like 2 years. Then you want to check if your duct still in good condition. What would be the method to check those ducts?
The first important thing is to try to avoid the opening at the manhole, especially. And the one recommended way is to put some kind of protection that could be easily removed in the beginning of the duct in any manhole. As this protection is in perfect state, the chance of some things going through is less. If you have some good ways to pass a rope with some soft material, okay? Imagine you have a rope and you have a soft material in the end, just pulling one extremity of the rope to the other. And if we start from the closed extremities, the closed ends, and if you have the ends closed in perfect position and pass some rope with soft materials, and it's almost clean, what you get, the idea is the ducts are in perfect conditions. If this kind of operation results in some portion of earth or something like that, it's necessary to remember how clean was the duct before, okay? Because a good recommendation could be to install the ducts, to clean the ducts before put the cable, and trying to put some cap in the extremity, especially when the duct is without any cable. After pulling the cable, it's better to put a kind of protection, and periodically, if you want, if there is some consideration relative to soil in between the two manholes, a simple test like that could give us information about the situation without using any camera and so. Of course, the more sophisticated device is use of camera, because you have the image, and sometimes it's necessary when you, in the first test, you perceive something you notice that something is not okay, because in certain extension, it was difficult to pull the rope with, even though the soft material, or someone noticed there's some different debris coming with the soft material, it's necessary to investigate more what is happening. And there are some simple methods, as using the water jetting, but sometimes it's necessary to have sophisticated method to investigate visually what is happening. Okay, imagine you put high pressure water jetting, and notice that the water is still going out with a bad appearance. That could be offset, or it could be a breakage in between, and the ducts are not protecting in that region, and earth, soil is just come with the other. Then, I think the main point that we need to have in mind that as better are the initial condition, as better will be the future situation. Then to install with supervision, to clean the ducts just before being installed, to close the extremity, to pass some rope before pulling the cable, just see the situation of the duct, putting the duct and protecting the extremity will help to avoid most of the irregularity. But sometimes when the duct collapses, or when we have an offset or a breakage of the duct in between two manholes, it's necessary to investigate and looking what we get off the duct in terms of soil and so, and eventually using a device that allows us to visualize the specific situation. It's not so easy if there is a long duct. As you mentioned before, 2 kilometers is a lot of distance. To investigate this in 2 kilometers is not so easy. Any other question? If not, we can move to the last topic of this chapter. It's maintenance in cable tunnels. Cable tunnels can also present some issues related to cracks and water leakage caused by deterioration of steel, reinforced concrete, and reinforced steel. The typical irregularities that can occur in tunnels are cracks, water leakage, and corrosion of the reinforced steel. If this kind of deteriorations are not corrected, are not repaired, in the future, probably the repair necessary will be in a large scale. Then is probably it will require more money and increase the cost in the future. Then it's better to carefully look at the tunnel and trying to realize preventive maintenance. Okay, and this preventive maintenance need to be done always in order to enhance the durability and serviceability of this tunnel. The first step for doing this is the inspection. Notwithstanding how well a cable tunnel is constructed, it will require preventive maintenance to preserve its integrity and to prolong its life. And this maintenance will necessarily require inspection and sometimes testing to determine the condition of the structure and also to establish the appropriate repair and maintenance measures. The inspection of cable tunnels could be performed to detect how is the extension of the damage or defect and how the structural safety and durability are affected. When crucial damage or defect are observed, it's necessary to have the experience of people to analyze appropriately and propose countermeasures such as repair of reinforced work and inspection to identify when it's possible. The recommendation is that we use the following ways of doing inspection. The first this is to use regular inspection. Then the idea is to visually check the degradation status of the surface concrete, paying attention to cracks, water leaks, or exposed reinforced steel. And in this stage, the deformation is detected and evaluated to determine if it's necessary detailed inspection, and also if it's necessary countermeasure to repair this defect. It's recommended that the procedure be established by the manager of this area, by the cable tunnel, that this inspection have some schedule and happen in a regular basis. These inspections are especially done by the observation, the visual observation, if necessary, the measurement of the crack to know and to follow the width of the crack using a crack gauge. This inspection is carried out using comprehensive identification sheets on which the observation and measurement can be conveniently recorded. Then the idea is to have a kind of report, a kind of measurement values, and a kind of pictures that allow to follow the situation and to take some decision. If necessary, it could be realized also detailed inspection. It's necessary when the defect and deformation are critical to the safety of the tunnel. And this inspection also can be carried out when the degradation cannot be identified by the visual inspection, or when we need more information about the degradation in order to judge whether countermeasures are needed and to select the optimal method to do this. At this stage, the detailed investigation of the measurement and deformation detected in a regular inspection are conducted by a specialist. The recommendation is that to analyze it visually, we can use the regular people of the company and so. But after some identification of abnormality, it's better to conduct this using a specialist in the materials used. Sometimes it's recommended also that this inspection use destructive testing of the concrete samples and also chemical analysis of the core samples to determine specifically and technically what is the degree of degradation. This kind of non-destructive testing still being used to determine the abnormalities, but sometimes it's important to get sample of the cement and to determine more technical information on the situation. Normally, there are two kinds of tunnels. The first one is the rectangular cross section. It's called box time, and it's constructed by a cut and cover method. It's made of reinforced steel concrete. The second one is a circular cross section, normally constructed by methods like shield driving, boring, drilling, and blasting, and after that the tunnel is jacked. The kind of normal abnormalities, usual abnormalities you can find in this, in case of concrete rectangular cross-section cable tunnel, are cracks, water leaks, and exposed steel. In the case of cross-section cable tunnel, the crackness line surface, water leakage, contamination or relation of line concrete in the span of line concrete. In each case, there is some recommendation for detailed inspection. In the first case is to look what is happening with the corrosion of the reinforced, with the carbonation depth and so. The second case, it's necessary to do a lot of analysis, and the different ones refers to the void between the line that form the jacket. This allowed us to have some consideration about the tunnels and to try to get a better understanding through some inspection methods. The handbook has a description of one of these techniques. I consider this more deeper information that we are generally dealing in this tutorial, but anyone is interested in know of one or other technology using for inspection can look at table 10.9. Generally, we have specific tests for each kind of damage found in the inspection. Some are non-destructive, and some are destructive. I think there's a mistake here because the visual inspection, it's not, it could be considered non-descriptive testing, but I need to check this. When a defect using this, when a defect is found in the visual inspection,